Danko Davidovic from Huber Engineered Woods here, and I'm Chris with LG Squared. We are here at the 1920s Makeover ATL project in Atlanta, Georgia, being built by Sawhorse Design Build. LG Squared is the architect of record, and we are also managing all of the passive house modeling and consulting. We design the mechanical systems. We are responsible basically for the structure of the home, the building envelope. And part of that building envelope, Danko, is using a lot of products, or using a product that we've come to trust quite a bit, is one with an integrated WRB, or water resistive barrier, which is behind us here, called Zip System. And it's a sheathing with an integrated WRB. So just, you're kind of at the heart of the science, the building science at Huber Engineered Woods. And so you do a lot of research and studies on this product, and we're doing some actually today. We're going to be testing it as it is installed today with all this liquid flashing. So tell us maybe the science behind this product. I know it was developed originally as a roofing system to integrate the roofing felt, and then they just sort of said, oh, let's just do it on the walls as well, which is where we are today. And so just kind of overview of this product and how it is, what's the science behind it a little bit.
Okay, cool. The first thing I like to mention, it's relatively new, but it's not that relatively new. It's hitting almost like more than 15 years being present on the market, and you can see more of these green panels around.
Yeah. See them. Yeah.
So the good thing about this particular product is like a structural sheathing that has like water resistant barrier integrated on the outboard surface of the panel during the manufacturing process, which is pretty neat. Not too many companies did that in the past. Some of them are picking up and kind of like conquering that technology lately. But having your water resistant barrier on the panel like eliminates the need to put any additional water resistant barrier on top of your panel.
Yeah.
In most cases, unless we are talking about the stucco walls and like wall absorptive claddings. The other good thing is you just tape the joints, provide continuous WRB. On top of that, you have like perfect air barrier. So.
And for a lot of the anyone who's not seen it or doesn't know what WRB is, the water resistive barrier is also, it's basically house wrap. So, I mean, house wrap is a term that people are used to, and that's usually put over, say, a plywood or an OSB sheathing, and it manages the water. It manages the moisture that might get onto the sheathing to drain it away from the assembly, because we want to keep it dry, we want to keep it protected. OSB and plywood are susceptible to moisture causing it to swell, causing it to rot, and that's why you put the WRB on in the first place. And now with this, I've seen it in the manufacturing process where they take, you take literally a 12-foot pile of sawdust or chunks of oriented strands, and you squash it down to this 7/16. And while you're doing that, you impregnate it with, if that's the right word, with this product, so which is
goes essentially on the wall, like piled 12 inches or 16 inches of organized thread boards mixed with adhesives and resins, and everything gets pressed and cured.
So it takes out takes out the step in the construction process of applying this roll product of the house wrap. And the thing about this liquid flashing, it's a very durable product. We use it. You can put it on concrete, sheathing, steel. It's the entire alphabet in one product. But it's a chemical that helps adhere to any product, any material, and as these two differing materials move, expand, contract, and move with the weather, or with wind, it moves with it. So it's an incredible product that we use, and it goes everywhere. The seams, the nails, the window openings, everything, to help create a continuous. It integrates with the integrated WRB, and it creates one continuous WRB around the structure, making your continuous air barrier, our air control layer, water control layer, and vapor control layer, all in continuous. And then you put your thermal control layer to the outside of that. So that's the beauty of it. And I think a lot of people are starting to catch on to this. The thing we're here to really, one of the things we want to talk about today is this liquid. You know, it's not common, but it is a very strong, durable, and even in the installation process, a little more forgiving than tape, because with tape you have to deal with potential wrinkles, and you're rolling it. With this, the liquid can find those gaps. You don't have the wrinkles as much. It takes a little bit more effort with the tape to get that a perfect seal, whereas this isn't quite as tedious with that.
Yep, to your point, like originally zip systems start just having like the tape instead of the liquid flash. So and the tape is good in most cases, goes relatively fast, but to your point, the one basic premise, you have to roll the tape. It's like PSA type tape, which is pressure sensitive adhesive. So you need to apply some pressure to get good bond on the joints. Like with liquid flash, there's no need to put any pressure. It goes maybe a little bit slower than the tape, but once you get to the speed and train yourself, it can go pretty fast. I mean, you've been playing around with this thing for years. So
and we've used it. We've used it, and used it well, and it's been a great product. And we've done houses very tight and very, very durable with tape, stretch tape. You have a standard, flashing tape. You've got some really strong products, and I know what goes into them, and I know that they get stronger with time, and they're really good products. So if they're used, no complaints there. Just got to be done correctly. Liquid flashing just again goes to everything. We've got foundation interfaces where you got concrete meeting plywood or sheathing.
So you apply the liquid flash here,
and the liquid flashing goes over the whole thing, and so it sticks to that concrete really well. And if we had any steel, it would go to that as well. So it's really, and that's what I mean by forgiving. And with tape, you'd need an adhesive. You'd need to spray, do a spray adhesive, and so it really kind of makes it.
You got my point. I'm a big proponent of using liquid flash, especially in these transitions from the bottom of the zip vault to the foundation vault. It's a great application, if you ask me personally.
Well, Danko, thanks for coming out to another one of our cool projects.
Anytime, my friend.
Man,
I enjoy it.
We're gonna be sharing a lot on this channel. I mean, all of our respective channels at Sawhorse, LG Squared, Home Performance Workshop. They're gonna be sharing something. Corbett Lunsford. There's a lot of stuff we're gonna be learning on this project and sharing it with everybody, and we'll have links to all those sites below. We'll have information about your product. There is a great interactive virtual walkthrough of this project that we're going to be adding to with these videos. I mean, it's a great process to follow, so anybody that's watching now can just be sure to follow along. We really appreciate everybody's participation and help, and we're going to share all the stuff we learn. I know screwed up, all the successes, all the failures, all that stuff that we're learning along the way, so we can share that with the world, and then show how we're learning from it and make it, because we're never perfect, and we want to make a better world. So anyway.
Everybody does. I mean, I'm really happy to be today here, because this is probably, I would say, the largest zip project I've seen with the liquid flash all over the place. So
cool.
And I'm just curious to see what you guys going to do on the board out there. So
I'm going to find out real soon.
It's a little different. I mean, real world is real world, and the STM lab tests are really different things. So
cool.
I'm excited.
Thanks, man.